Hello, and welcome to another Into the Terminal. Today, we're going to be talking about building applications into containers. So, why don't we just jump right into the terminal?
That is the point of the show, isn't it?
It is.
It's in the name.
All right. So, to get us started on our critical path today, we're going to build a very basic website container. And I've already made my index file, right? Super awesome. There it is. And we're going to take that, we're going to shove it into a container. So the first thing we're going to do is we're going to pull down a base image from which to work. And there are a couple different places where you can grab base images. I'm going to use the Red Hat Enterprise Linux, or actually I should say the Red Hat Universal Base Image for RHEL 9. And I'm pulling it from the Red Hat Container Registry. We could also find it at Docker Hub if you're interested. And after the transition, maybe we'll talk a little bit about why you would use a builder or base image instead of building something from scratch. So after buildah pulls this down and puts it into my local image registry, it actually mounts it as well. And here's its working name, UBI9 working container. And I can use this with future builder commands to talk about this container image that I'm building. And so we could do things like install additional software into it. So here we're going to run a command against UBI9 working container. And the command I want to run against it is a dnf-y install HTTPD, which is going to give me the Apache web server installed inside of my container image.
Now, the double dash there, that's not a command line argument. That must be something. Is that some kind of a redirection, or it says run this in the container?
Yeah, so it is a command line argument.
Okay.
But it's this separation between the buildah command that says we're going to run something in the container and then the actual command we want run in the container.
Okay.
So let me just recall that from history here. So the beginning of the buildah run and my working container, that says I'm going to run a command and this is the container in which I want to run it. And then after the double dash, this is the container, or this is the command I'm executing inside of that change rooted container environment.
See, we're discussing this a few seconds ahead of the stream, and someone in the stream just asked, Conan Kuda just asked, what's that double dash all about? Now you know, Conan.
There you go. All right. So we're going to do a couple more things on our container to manage the software that we just put into it, right? Because we're designing a web server container. And so when we're thinking about like running a web server on a machine, you have to install the web server software. You have to turn it on so it comes on when the machine boots. And then we need to put our content into it, right? So we're going to, whoops, helps if I don't have a copy paste fail. Try that one more time.
Copy paste is hard.
It is. All right, so we're going to do another buildah run. We're telling it the container we want to run it in, and then we're going to run the command systemctl enable on my Apache daemon, just like I would on our regular system. All right, now we're going to do something that's container specific. All right. So we're doing a buildah config port. And basically what we're saying is when this container starts up, right, when it runs the init process, it is going to be allowed port 80 on the container. So because Apache is, here, let me clear my screen as well because I'm being told that my command is not coming through.
We've ruined everything.
There you go. I have. All right. So we're going to configure the container so that container has access to container world's port 80. So I'm doing all of this stuff as root, which means that when I run the container as root, it gets all the rights and abilities that I have as root, including connecting to privileged ports. But this is specifically that when the container starts up, there's an entrance into the container for port 80 on the container. And that's independent of what the host is offering listening ports for. And so we'll see when we actually run this container how we direct where connections go between the container host and the container itself. Um, all right. Whoop. Let's try that again. All right. So there we go. The next thing I need to do, or I should say at this point, my container is a web server container. When the container starts, the web server is going to start. And if the container receives port 80 connections, they'll be passed through to processes running inside of that container. So the next thing I need to do is put my super awesome website into place. All right, so for that, I'm using build a copy. So build a copy is going to copy from my local system's file system into a place inside of the container's environment. So we're going to copy into the UBI9 working container file system the local index.html file, which is in my current working directory. And when it goes into the container, it's going to go into the var www HTML directory inside of that container environment. All right, so now I have my container set up to be a web server. I've got my web content positioned within the container file system. So now it's time to mint that into a runnable container. So we're going to do a commit. We're going to take our UBI9 working container and we're going to make a container image out of it called Awesome Website. I know you're shocked by this name, Nate.
Awesome. It's awesome. It's see, I've got a claim to the super businessy website. You've got a claim to the awesome website.
Yeah, well, because awesome website is better than this super businessy website.
Super businessy is boring, right?
All right, so we can actually see that this image was created by doing a Podman images, right? And there it is. So we just made the in our local repository container image called Awesome Website.
Awesome.
Okay. But now we have to run it. So we got the image. Now we have to run the image. So we're going to do a Podman run. All right, so we're running our container, Podman run, -D in a disconnected way, right? So we're not going to interact with the container. It's just going to run behind the scenes. And when we were building the container, we made it so that Apache would start in the container automatically. So that's the process that's running behind the scenes in this disconnected fashion. If we hadn't done some of the config setup and whatnot, what would happen is we would start the container and it would run something like a bash shell or something and then immediately close and exit. So during the configuration, when we were building the container, that's what we actually specified that it should run the Apache service, and then that'll keep running once we invoke it. Then the -P. So this is the port thing I was alluding to earlier. So the first port is the host port. So on my local system, port 80 traffic comes in. And on the other side of the colon this is where it should go to the container. So incoming port 80 to the container host goes to port 80 on the container and whatever service is listening on port 80. And then the last thing is what actual image we want to execute with this Podman run.
For folks listening, this is really similar to like NAT port forwarding. If you're familiar with how NAT port forwarding works. In fact, I think that's literally how it works.
Yes. And this is where also if I was doing it as a unprivileged user, we could bind to a high level port on the container host,
Right.
but still send it to port 80 inside the container, whatever process is listening to port 80 in the container.
And we can certainly go into why that's important after the break, but I just wanted to kind of note that. Same concept, same technology.
All right. So it's running, or at least you believe me that it's running, because there was this huge hexadecimal number that was assigned to it that's this unique ID.
I mean, when there's
So
when there's a big number on the screen, it means it worked, right?
that's right. Surely.
It'd be
All right,
better
so
if the
we can
number
use
was
something.
green.
We could use something like Podman PS. So this will show me my containers, and -A says show all. So if they're stopped or exited or whatever, they'll show up too. But right now we've only have one container that's running. So here it is. The first part of that really gnarly number that was printed out, that's its unique container ID. So you could use that really gnarly number. Or under names, we have Gallant Maharva. And that's another way that we can refer to it that's a little bit easier to type than FFB 12
I don't know.
1F D8
That's
6C6.
a toss-up. Which one of those is easier to type?
Fair.
Mahavira?
So we're running the daemon, which in this case is Apache. It was created 22 seconds ago. And then we are also told like our port configuration. So we can see that on incoming connections, any incoming IP port 80 on the host, it's going to port 80 in the container. And then we get its easier to type name, although Nate argues with that. Okay.
You're going to copy and paste these anyway. It doesn't really matter.
So let's take a look, shall we? I'm going to have to share a different terminal, so wait for 1 second, and I'm sure producer Eric is going to toggle my screen a little bit. Okay, so this is the web console running on the container host, but what I want to do is I just want to reuse this window and change it to a regular HTTP, and not port 9090, but the normal port 80. And there is my super awesome website running from my container.
Yay.
Yeah, and we can prove that because if I kill my container and reload this page, it should fail. So we're going to leave the page here in place, and I'm going to go over to my terminal and kill it off. So producer Eric won't have to switch around the screens yet. Okay, so I've killed it off there, and I'm going to reload the page, and it's just spinning. You guys can't see it, but it's just spinning in my browser because the process that was serving this, that container, I killed off on the container host. So eventually that'll time out and die off and give me an error about not being able to connect to it. Eventually. Come on. Darn you, web browser, time out faster.
It's probably a full 30 seconds it's going to wait, maybe even longer. So, trust us, folks. So I guess we could talk a little bit about a few other options there, right? So like that name, for example, you can specify a name. That's generally do when I'm setting things up. I'll name them so they're a little more intuitive. So it's not just like, oh, what does container Bobby Jones do? I'm not sure. What port's it on? Right? Name it something that's a little more intuitive, like super awesome website. Waiting.
All right.
Yeah.
So I'm tired of waiting, but you guys can't see it, but my little browser like reload thing is just continuing. Oh, maybe if I hit a shift reload, hold on. There we go.
That's better.
Oh, yeah. Use the keyboard shortcut, Scott. All right. So that's because the container that was servicing that website has been killed off. And so we can share the other screen again. and you can see the kill command that I issued for it. And producer Eric will be kind enough to like toggle it back on.
Ta-da.
All right. So that Podman kill Gallant Mahavra. I know the Shantanu said how to say it, but we're gonna butcher it anyway. Was killed, and if we do a Podman PS, right, we can see that it is exited 2 minutes ago because that's how long I waited before using the right keystrokes to show you that it wasn't working. So that was indeed being served by my container. All right. So stay with us after the transition, which is a little bit delayed today. And we'll talk about some more examples and a little bit more depth into what we're doing here with containers. Hey, Nate, how's it going?
We have returned. Wait, there's all kinds of stuff. Okay, we're good. That producer guy, he's got to be faster with the buttons.
So, Nate, how terrible of a job did I do building containers?
You did fine. There was one question that came up in chat that I've actually always kind of been curious with this particular demo when I see you do it. You use systemd and then call it at the end instead of directly running the application. Now, most container how-tos and builds and best practices that I've seen generally say don't do that. You shouldn't run a full init inside of your container. You should just run the process you want to run. And I'm curious if there's a reason why, or if it's just your own personal preference.
So for me, it's a personal preference. In fact, it's like two things. One is the enablement. There actually isn't a full running systemd in this container. What we do have is an init process that will run enabled units.
Okay.
And so when I did that systemctl enable Apache, that enabled the unit. And then the init process just starts the enabled units. It's not as comprehensive as systemd. And because the only enabled unit is Apache, that's what we get.
Right. Right.
So I do it that way because I like the consistency of system administratoriness rather than just like, yeah.
Because normally, like what you'd have to do is if you run it in the traditional way, which would be the command at the end is the thing that calls your process. You have to know what to call, right? And on a standard RHEL system, you don't care what to call. You just enable it through systemctl. So I can see why that would probably make it a little more straightforward. Now, I don't know that there's a really like a huge argument one way or the other. If it's a stripped down systemd, it's probably not as heavyweight as a full init system, right? So there you go.
It literally is not a systemd. It's
just a
it's just a init that runs unit files that are enabled. That's it.
Okay.
And so there's
it's sort of the same thing. Just a different way to call it. Not the same thing as systemd. It's sort of the same thing as calling your thing directly. It's just you've told it by using the unit file.
Correct.
Okay. So there's the nuance.
Yeah, and there is a UBI image that includes a full systemd implementation. It's called UBI init. So there's 4 flavors of universal base image from Red Hat. I used the standard one called UBI. Shocking. There's UBI init, which is a full systemd implementation. So that one is great if you have maybe a more complex series of applications. Like if you're trying to do a virtual machine to single container switch, that might be a method for getting you mostly where you need to go because it has the full systemd implementation like AVM. But it is larger in size to get going because there's more software in it. Then on the other side of that, there's the smaller images. So there's a UBI minimal, which is smaller than standard UBI. But the way that we get it smaller is by installing both less software and instead of a full DNF implementation, there's a DNF implementation called micro DNF, which is also the same command that you use for interacting with it to install software. And so the way that they strip it down is they have some of the system tools stripped down as well. And then the fourth image is called micro, UBI micro, and it's literally something like 13 packages because that is the exact list that you need in order to get a bash shell to install and run.
But what if I don't want a bash
Um,
shell? Can I make it smaller?
You can, and it's called building a container from
Yeah,
scratch,
right.
which is where you literally position all the files and directories and stuff that you want inside of it.
And I'd
Um,
imagine that tiny micro, I think you said it was called, is meant to be on par with like Alpine or something. That's really
Correct.
common for really lightweight containers. So
Right. And that's really what it's about, is like providing a similar to Alpine experience. And there's a bunch of people that are like, well, it's like 1 megabyte bigger than Alpine. It's like, okay. Um,
splitting hairs.
but right. I would say that for most people, that's probably not where they want to start in their container journey.
Right.
Right. They want to start with tools and practices similar to what they already use for system administration.
All right. Oh, we have another one. DNF install, make clean inside my normal Docker file. I think the answer is yes.
That
Right?
is
So,
correct.
yeah.
So
Yeah.
it is when we do a buildah commit that we actually make the overlay on top of that image. So I have another example if we have time to do it where I reuse that same image, but because it's still mounted and I put my more stuff in there and then I do another commit, I'm still only doing a single layer of image on the new container that I'm making with all of that accumulated content. So that's one of the other reasons why I like buildah, is because I can like do all this stuff in one go, and then when I do the commitment, that's when it actually makes the layer for the image overlay.
Okay, right. Because when you use a container file, it'll make a layer per command, right? So is that the difference that you're trying to?
So I know that that's the way other file-based builds run. But see, Nate, you're asking me questions that are actually next week questions. That's
Okay.
future Scott questions.
All right. By the way,
But
next week we'll be talking about containers again. So
exactly. But yeah, we're going to talk next week about operationalizing containers, which is going to include things like building a file that will allow you to build this container. So instead of typing all the commands by hand like we're doing today, you
right.
can just like pull down your updated image, execute this series of commands against it to generate the image that you want out the other side. But that is not a question for today.
Right. All right. So do we want to get to your next demo so we have time for that? Or well, I guess we are. There we
Yeah.
go. There's the terminal.
Producer Eric says yes.
Yep.
And we will
Demo is
comply.
next. Demo is next.
Before we do that, just wanted to remind you all to smash that like button. And if you enjoy the content, don't forget to subscribe to the channel so you'll be told when we're doing these live or when we've produced more of them. And if you think you have a friend that would also benefit from this episode, go ahead and share with them. All right. So Nate, quick question. Would you rather do an example where we add a third-party RPM repository and install more RPMs that didn't come from the UBI repos? Or should we take a already developed application that's not packaged and use our container image as the method of packaging it?
That's a tough one. I almost want to ask the audience, but we're not going to hear from them for another 5 or 10 seconds. So I think packaging would probably be a more valuable demonstration. And if folks in the chat disagree with me, maybe we can either try to touch on it after, or we can make sure we cover it in our next episode, perhaps.
Yeah, so Shantanu is the opposite of you. He
I
wants
see.
to cover
Yeah,
people.
this is how this works.
So how would I try to do both? We'll see if we can do it quickly enough. How about that? Because I'm talented. Okay, so here's what I'm going to do. We have this application. I'm just going to pull it out of GitHub. And here it is. There's all the application data that I just slurped out of GitHub. And so one of the reasons why containers are interesting is because they are actually a method of packaging software, right? Just like RPMs are a method of packaging software, a container can be that as well, if you think about it, because it's really just an archive of files and content. Same thing as a RPM. It's just a different way of maintaining that portability to move it between systems.
Right.
So here's this like unpackaged thing, right? It could be a tar archive, it could just be a random collection of files like this that I pulled out of some Git repository. But I want to take this and put it into my container. So I'm going to continue to use the working image that I've already got. And what I'm going to do is I'm going to copy into that working container image this clumsy bird directory. And when I put it into that container image, I'm going to put it into a directory called clumsy bird under var www.html. All right, so the UUID there tells me that it was successful. And we can now make a committed image. So I'm going to take this working container and I'm going to create a container image called WebGame on it or out of it.
So the buildah copy essentially made the change, but didn't write it out, didn't write it to the image, right?
So when we used buildah from, it downloaded the UBI image that I asked for.
Right.
Then it also mounted the file system of that image into my directory tree. And so when we're doing these things like build a copy, we're literally just copying stuff from wherever in our local container host file system into this change rooted container image file system.
Okay.
But because I've not disconnected that container and put it back again, it's all still a single file system and a single instance of that file system. So if you looked, my super awesome website image or index is still in there.
Right. So if you were to, I don't know, kill the process or the machine were to reboot or whatever before you committed, the change wouldn't actually be in the container image yet. It would be in this it probably wouldn't even exist on the file system anymore. It would just be lost. Is kind of what I'm getting at, right? That's the difference between before and after you've run the commit.
Right. Okay. And so the commit is where we're saying, okay, take this file system image, this archive of files that we've created, and mint it into a container that I can then invoke and run.
Right. But it also means that if you did a thing and then thought, oh, that wasn't the thing I meant to do, you could undo it and do it again or do something different before committing. And it's not really hurting the container, the image.
Or recommit it again, in which case it just overwrites with the new.
Right.
Wow, that was ominous, Nate.
Yeah, there's totally a nasty thunderstorm running through right now. So if I drop, apologies.
All right. So we can see in my local repository, we have WebGame, right? That's my image. And we're going to go ahead and run it. And I'm going to basically do the same command as before. And let me clear my screen so you guys can see it. I'm going to run it. Port 80 goes to containers port 80. But now instead of running the awesome website container, I'm going to run the WebGame container. And now we're going to swizzle the screen shares again. Okay. So when last we left this browser window, we had disconnected our container. And so when we tried to refresh it, it failed because there was no process listening on it. But now we started up WebGame and it is back to listening on port 80. So if I reload it, and so there's my super awesome website that is running in this container. And then also if I go to the directory clumsy bird, there is my web game that's running, right? And we can see how terrible that I am by moving along. Right? Oh, and I failed. And you guys aren't probably hearing the awesome music that comes out of it too.
We're getting the music and everything, so that's why.
Oh, really? Excellent.
Sorry, I was muted because of the thunder. You didn't hear me talking, but yeah, that's why I started dancing.
Yay, magic of internets.
Yeah.
All right. So there you go. And because it's still running, I can take a look here with PS, Podman PS. Right. And so Gallant, I'm not even going to try, you guys, is exited, but this one, Romantic Jang, still running, right? So we could do a Podman kill Romantic Jang.
Poor Jang. He's so romantic, and we just killed him.
Now it's exited, right? And again, if I tried to reload that page, it would fail because there's nothing listening on port 80 anymore. All right. So we're 2 minutes over. Let's see if we can do a quick rundown of installing extra packages for Enterprise Linux and another thing. Instead of reusing the same container image yet again, I'm going to start fresh. All right, so let me clear the screen.
So while Scott's copying things, one of the reasons that you might put things on a different port, like I was talking about earlier, that I said we'd try to talk about, is if you had two containers, for example, that are both running web, right? They can't both be on port 80. So you might put one on 80, one on 81, right? And then you can do things to map into either of them, right? Like you can use, there's more complicated ways to make that happen. But if you went to port 81 on your host, you'd get to the second site. 80, you'd get to the first. Or again, like Scott mentioned earlier, if you're running as non-root, you can't use 80. You have to go above 1024 because that's just how privileges work on a Linux box. So, okay, back to Scott's demo. But I wanted to touch on that because I said I would. Man of my word.
Okay, so I did a buildah from and the same registry URL as I did last time, except you'll notice that it didn't download anything or give me any statuses. That's because that image was already downloaded in my local repository. So it just created another file system instance and mounted it in my directory tree, and they called it UBI9 working container 1 as opposed to UBI working container. So now I actually have two separate file system images based on UBI9 that I can interact with, but I have to use different names for interacting with them, right? So now that I'm building this brand new container, when I'm using my buildah commands to copy stuff in or to run commands, I'm going to refer to it as UBI9 working container 1. I could have also like used some extra options with buildah to specify a name I wanted to use rather than letting it auto assign me this very uninventive name. All right, so.
This just tells me that Podman developers are just as creative as you and I are.
I mean,
they just added a 1, and that's it. Done.
Dan Walsh is not a mind reader. Okay.
Podman, now powered by AI. It can read your thoughts.
So here we are running a command inside of this change-rooted environment, UBI9 working container 1. And what we're going to do is we're going to download the EPEL release RPM and install it inside of my container. All right, so once this is done, that means that I'll be able to do things like install software from extra packages for Enterprise Linux into that container. And we're going to install not whatever it was that Shantanu suggested, because I'm just going to ignore him for a minute, but instead something even more dumb, which is a text-based Moon Patrol game. All right, so inside of our working container, we're going to do a DNF install of Moonbuggy. And Moonbuggy is a text-based, a terminal-based Moon Patrol clone. All right, before we actually make the committed image and stuff, I'm going to prove to you that this is actually in the container image and not on the container host. Because what I'm going to do, you just saw it successfully install something, but if I try to run Moonbuggy, command not found. Because when we did the installation, we did it inside of this file system of my container image. So when we pulled down the RPM and we spread its files all around, we did that within the confines of that container image, not on the host machine at all. So I'm going to make my commit so we can then run it. So I'm taking what is currently in UBI 9 working container 1, and I'm minting a new image called game container. We can see it right here, 12 seconds ago. And then we're going to Podman run. Now we're going to do a little bit differently.
Yep. I was just going to say the IT makes it interactive, right? So we're essentially going to get a console in the container once it comes up.
Right. And the thing that we're going to attach to that interactive session is this command. So if this command was something like an ls, it would ls exit and then my container would exit.
Right.
So for this, we'll see the Moonbuggy application. And then if we quit it and it dies, that will kill off the container too.
Now, this is good for more than just, you can go ahead and run it to start your demo, but this is good for more than just running Moonbuggy in a container. This is good for troubleshooting, right? If you do the same thing with, say, the Apache container that he ran earlier, you'd get a shell in the Apache container. So you could do things like, oh, what does the config file look like in the container? Or did my stuff end up in the right path, right? That sort of thing. However, changes you make in there will be lost when the container gets shut down. So just keep that in mind. Oh, you crashed your Moonbuggy.
I did.
Was that a wheel or was that like the dude's head? That's terrible.
And then I can quit and quit out of the. Oh,
You get the high scores first.
I did. I got the high score. Except now that I killed the container off, that high score is dead because
no more high score.
The file in which it was stored is now gone because the container has exited. Right. Though I guess I could put it back because it's still on the list.
And maybe we can do this in a future episode, but you can also like attach to a running container and get to that shell. So you can do debugging or troubleshooting, just, things to keep in mind. A lot of people get confused by like, oh, my process is running, but I get no visibility into it, right? And I think there's a whole bunch of things you can do to get that visibility that you're used to having from something that's running and logging in systemd and writing out its log files and whatnot. They're just different when you're in a container. So we'll have to add that to either next episode or maybe a third episode about containers.
All right, so that runs us off our list of demonstrations today. So Nate, any parting words of wisdom?
I haven't been struck by lightning yet, so we're doing good.
All right, right on.
I'm serious. That's a close storm.
Yeah, I feel you. The other day there was a lightning flash and a thunder crack at the exact same time, and I was like, "Wow, that's like literally right here."
Yeah, that's about how that just felt. I literally heard the pop in my headphones. So the interference in the atmosphere literally distorted my headphones for a moment. Pretty close. Anyway. Yeah, so Podman, in my opinion, is a really useful tool. It's a really good place to run containers for folks who maybe don't have the need for something as large and complex as OpenShift or Kubernetes. I run a bunch of personal websites, and I mean, heck, Valheim, Minecraft, right inside of containers on my own, either in my lab here at home or on a cloud host that I run my websites on. And it's really stable, works really well. You just don't get the manageability and whatnot that you get out of a fuller or a larger, more complex, what's the word I'm looking for? Management implementation like Kubernetes and OpenShift give you. But great for learning, for development, or for smaller use cases.
Yeah, and there's an old joke that's like, developer says, worked on my laptop, and the response is like, fine, we'll just ship your laptop then.
Yeah.
Just did, right? When we took that,
right.
something Word application, right? We could have put in configuration files. We could have edited those files and changed them around. As long as it was happening within that containerized environment, when we're finally done with all those customizations, that's the state. And so we can then take image and start shipping it around, and everyone is getting the same thing in the same state.
So you
have to download RPMs and make your own config changes and other stuff.
Yeah, you compared a container to an RPM earlier, and I just wanted to sort of drive home that it's sort of like if you were to take an RPM, all of the RPM's dependencies, and the system that it runs on, right? And all the libraries and dependencies that come with that, and put it into an image, a machine image that doesn't include all of the underlying kernel and whatnot. You've got a container, right? So it's the process and the libraries that it needs all in one place. You can run that anywhere. It should behave the same as long as it's on a compliant container engine, right? It should run the same anywhere you put it, which is the beauty of containers, right? It's like RPM plus plus plus.
All right. So that's where we're going to end the episode today. Thank you for staying with us. I know that we're over our 12 minutes over our 30-minute attempted time span.
But it was valuable, Scott. Valuable.
I mean, Shantanu asked, I had to comply.
And we got that dramatic lightning flash. If we would have stopped at 30 minutes, you wouldn't have got that.
So join us next week when we cover containers again, but now we're going to talk about operationalizing them, right? So now we've built them, cool,
right?
But we have to talk about things like tagging, which is how we version containers. And we'll talk about container files, which is how we can more automatedly build the container images so that we're not having to type this series of commands every time we want to make an update to the container image. And we'll see what else we can mix in there too.
Yeah. I really think that either an episode or part of the next episode should cover like troubleshooting and whatnot. Like, how do I get logs? How do I get a console? How do I do things on my running containers? Because I think that's like I know that was a stumbling block when I got started with containers. So it's might as well share it, right?
So we did a troubleshooting arc a while ago. Maybe we need to start putting a couple ideas in the hopper and do a secondary arc. I think that would be a great one. We're talking in the green room before our show about troubleshooting boot and like all of the cool things that systemd provides. So maybe we'll do that not next week, but in a future episode.
There we go. Automatedly. Yes, that's totally a word.
All right, everyone. Thanks for joining us today, and we will see you next week. Also, don't forget about RHEL Presents, which is avoiding obsolescence with in-place upgrades. So Eric will be covering doing in-place upgrades with, I'm guessing, the Leap utility, because that's how we do it now. For upgrading RHEL. Until next time.
I'm going to go to a hurricane bunker. See ya.